Chapter 18, Aqueous Ionic Equilibrium. And this is a quote from Otto Witt. In the strictly scientific sense of the word, insolubility does not exist. And even those substances characterized by the most obstinate resistance to the solvent action of water may be properly designated as extraordinarily difficult of solution, not as insoluble. And so this sort of illustrates one of the changes in thinking between Chem 1A and Chem 1B. Chem 1A, we think a lot in black and white. This is soluble or it's insoluble. Now that we're studying equilibria, we're going to recognize that, well, even something that's considered insoluble might have like 2 formula units dissolve, right, in a bajillion molecules of water. So is that 0? No, it's not 0. Is it essentially or practically 0? Yes, but it's not 0. So let's talk about antifreeze, which, ironically, my daughter's radiator hose burst yesterday, so we had to go buy antifreeze. Antifreeze is dangerous, especially to animals and small children, because it tastes sweet. So, if you've got antifreeze that's sitting in an open container or spills and sits in the gutter, dogs and cats may come up and lick it, and it can kill them. It has ethylene glycol in it, and that has a sweet taste. Ethylene glycol is an alcohol, and so the first symptoms of antifreeze poisoning resemble drunkenness. But then the ethylene glycol gets metabolized to glycolic acid. That enters the bloodstream and affects the acidity of your blood. So the acidity of your blood is super, super important, your blood pH. A lot of proteins will only function in a range 7.36 to 7.42. That's for humans. So if you get above or below that pH, things don't work well anymore, and that can kill you. How does your blood maintain its pH so closely? It does so by the use of buffers. So a buffer is a system that resists pH changes by neutralizing acid that's added or base that's added. So one of the important buffers in your blood is mixture of carbonic acid and bicarbonate ion, or hydrogen carbonate. So carbonic acid is a diprotic acid, and it can ionize and form, let's look at it this way. The carbonic acid can neutralize hydroxide that's added, forming bicarbonate ion, hydrogen carbonate ion. The hydrogen carbonate ion can neutralize acid that is added. So if we have both of these in solution, we can neutralize acid or base that's added and maintain the pH. But if you get large enough quantities of glycolic acid in your blood, it overwhelms the capacity of the buffer and the pH drops to dangerous levels. And you've probably heard of something called ketoacidosis. That is also your blood becoming too acidic, and that can kill you. Yes, here it is. I didn't read ahead. So acidosis, low blood pH. This affects the equilibrium between hemoglobin and oxygen. And we talked about this before. So hemoglobin can be protonated and act as an acid. Then it reacts with oxygen, picks up the oxygen, and dumps off the hydrogen ion. Well, if there's too much hydrogen ion in your blood, if your blood is too acidic, that affects this equilibrium, shifting it to the left, making the hemoglobin not as able to carry oxygen. So your heart's pumping, your blood's moving around, the hemoglobin's there, but because of the additional acid, it's not picking up enough oxygen. So, interesting treatment for antifreeze poisoning or ethylene glycol poisoning is the administration of ethanol. So give your dog vodka or beer or something, because your body preferentially metabolizes ethanol over the ethylene glycol, and so that will keep your body busy while you get rid of the ethylene glycol. Any questions? There's chemistry in everything.